Hey guys, welcome back to my channel and this Okuma LS Adventures, where I share my progress of working on this nice Japanese lathe. In the last video I mounted the DRO on the crosslight and the display, and the next step in this video is starting to mount the linear scale for the Z-axis here on the back of the machine. The linear scale that I have is a Sony Magnescale. It's a nice length and size for this machine, and luckily the machine has some mounting flanges here in the back that I can use, so I don't have to drill many new holes, so that's good. These are normally for the taper attachment, but I don't have that and I don't think that I will buy it or use it a lot, so I can use these with some extra brackets to start mounting the linear scale. So that's what this video is about, and yeah, let's get started. What I will do is I will buy a piece of cold rolled steel and mount that all the way from the headstock to the tailstock of the machine, and mount it on these threads for the taper attachment, and only mount it drill one extra hole here on the casting to support it here at the end. I could use direct mounting of the two bolts for the linear scale on the casting, but I will also use the long cold rolled steel as a support for the cover that I will mount on there. So that's why I use the combination of the cold rolled steel as well. So these Sony Magnescales have a magnetic rod inside, so that means that it is only supported on both ends, and there's quite some movement on the rod with the sensor. But if I push it all the way to the end where it is fixed, then the movement is very little up and down, and then I can take the measurement, and for normal did a few tests, and it is 1.7 millimeters. So I did the same on the z-axis linear scale and measured it at both ends, and now here in the center I can just push it with the shim in between and then mark the hole. The construction will be like this, so it's nicely pressed against the top, and this one will be welded on here. So now I can stripe that and drill and tap these holes. So I'm not worried about this distance. I know that that is exactly 50 millimeters, but the height looks the same, so that's good. So I'm trying to measure the distance that I need to put a block in between there to get it nicely aligned, and I'm using gauge blocks, and this is all nice and square to the frame. Bottom side is nicely on the right height, so now I can check the squareness on this bottom block here. So this is 24.5 millimeter gauge block in between, and you can see that bracket in the back is slightly tilted. So let's try 24. So this is 24 millimeters in between, and now it is nice and square. So let's use that, tack it together and check it. Yeah, still nice and square. I will weld the top side here first, and then this corner, because the corner will pull a little bit more than the flat weld, so hopefully then it stays nice and square. But first let's tack this other part, and then let's do a test fit. So the holes still line up nicely, easy to turn both. Yeah, happy with that. I can always adjust it a little bit up and down on here, but the distance here looks good. Yeah, also good on here. I couldn't get in here all the way, but I think it will hold. It pulled just a little bit, but not much, and the sensor can compensate a little. So I'm happy with that. Part is finished, and let's finish it by chemical blackening and give it a little bit rust protection. This is always so satisfying to watch. Just like this process. Gonna leave it in here for a few minutes and then give it some protection oil. Small little detail, I made the bracket just a little bit wider than the sensor, so if I bump into something I'm always sure that I will hit the bracket and not the sensor. So after all the test fitting, there's still one thing left to do, and that is drill a hole here in the casting. I waited until I was sure that I was going to mount it in this position, but I'm happy the way that turned out. So now I need to support it here in the end because it's still moving a little bit. So just need to drill one hole. The other ones it's fixed, but this one needs support. So I will scrape this flat and then drill the hole, put a spacer in between, and then everything is good to go. So it's getting pretty close this direction, but let's check how the movement is up and down. And it is a lot higher here in the top of the casting, and if I mount it this way then the whole bar will twist, so I need to scrape a little bit more on the top here. Let's use a power scraper. So these planes are not exactly parallel. It moves around 0.1 millimeters on the height of the bracket that I'm using. It's the same on both, so I will use that also for the mounting on the headstock side. So it's okay if it's 0.1 millimeter difference there. So let's check that again. So it's still a little bit more on this one, so still need to take off some at the top, but not much anymore, so I will do the rest with scraping. So now it has around the same parallelism as the other mounting places, around 0.1. Let's check the linear movement. Just one problem with scraping, I don't know when to stop. But I call this good. So the next step, drilling and tapping this hole, and there will be a bushing in between this bar and the casting, and I already made that, but I left some of the stock on there and drilled a hole that is the same size that I need for the for tapping, and now I can use this as a guide for the drilling. So we'll mount it and then start drilling. I left it a bit oversized, the thickness of the spacer, so it's a tight fit, but not much. So yeah, these tabs even have the drill size on there. So the cold rolled steel is not entirely flat with the casting or the parallel with the bed. There's a little high point on here, but the linear skill is only mounted on 2 points, one over here and one there at the end. And even if there's a high point, it's nicely zero here and on this point, and then it goes a little bit negative to the back here, and it's minus 6/100ths of a millimeter where it is mounted. So that's just a little offset from parallelism, and that is fine by me. While I'll have this cold rolled steel off the machine, I'm drilling a few holes and then tapping it with M5 for mounting the protection cover. So I want to grind a nice chamfer here, a 45-degree chamfer, and I have a long support arm on the grinding table. It's on 45 degrees and it's slightly on an angle this way, so that way it will only hit the belt on this edge here, and then I can just pull it through, and I have some adjustment with the belt alignment left to right, so if I move it a little bit to the right, I get a little bit deeper chamfer. So let's try how that works. So that worked quite alright. It's almost the same size bevel that is on most parts of the machine, so that's a good fit all the way to the end. And this is the back side, just a very small chamfer. Good job, grinder. Works great, guys. So that was it for now. Z-axis and X-axis DRO are done. Next step is making a nice protection cover and figuring out a good way to mount all the cables. So that will be the next step and the next video. So for now, that was it. Hope you guys enjoyed this Okuma Adventure series, and hope to see you guys next time. Bye bye.